Okay, so last part of this video, we are going to be talking about our shifts now. And just kind of a reminder for you guys, our stuff on the inside causes horizontal changes. Stuff on the inside causes horizontal changes. And don't forget, when it's on the inside, we do the opposite. So if it looks like it should go to the right, it actually goes to the left. Okay. Outside is going to cause vertical changes up and down. And then also add on here, I probably should have done this. Remember that your negatives cause flips. They're going to make things flip. Same rule applies for negative though. If the negative's on the inside, it flips horizontally. If the negative's on the outside, it flips vertically. So where is the outside and where is the inside? Some of you guys might be able to guess this already. But anything that is out in front of the logarithm is considered on the outside. Okay. There cannot, well, I mean, there can, but for our graphing, there's not going to be anything down here in the base. Okay. So it's just going to stay. It's just log base. And then in order for it to be on the inside, it is going to have to be inside of parentheses. So the only way that a horizontal change will happen is if there is something in the parentheses in here with an X. If something is added or could be subtracted back behind, that is considered on the outside. Okay, so much like with our parabola, the only way you have a horizontal change is if it is in parentheses. Okay, so we're going to go through just 3 examples here of single ones. We've got a horizontal shift. Okay, they've asked us to graph y equals log base 2 of x plus 3. Okay, so how do I know that that is a horizontal shift? We'll look where that plus 3 at. It is inside of the parentheses. So that's inside, which is what makes it horizontal. Before I get going on that, let's go ahead and graph my parent function. So the parent function for this one, y equals log base 2 of x. Okay. So we're going to draw our table. Got x and y. Remember, with our logarithms, we know our y's. So our y's are -1, 0, and 1. 0 always goes with 1. 1 goes with the base. This is a base 2. So the -1 goes with the reciprocal of that base. So it's going to be 1/2. So I'm going to graph my points. 1, 0, 2, 1, 1/2, -1. And then don't forget, I do have a vertical asymptote here as well. There is my parent function. Okay. Now, we said that this was on the inside, so this is going to cause a horizontal shift. Remember, we do the opposite on the inside. So since that plus 3 makes me think I'm going to go to the right, I'm actually going to shift each of these points to the left 3 spots. And what else moves 3 spots? My asymptote will shift over 3 spots as well. Okay? So everything shifts to the left 3 times. And there is my finished logarithm function. Okay? Next, with my vertical shift, I've got a log base 3 of x plus 2. Okay, how do I know that this is a vertical shift? This is not inside parentheses. Okay, so that'd be on the outside there. That's how I know that it's on the outside, which is what causes that to be a vertical shift. So I'm going to start graphing my parent function here. Y equals log base 3 of x would be my parent function. Draw my table. X and y. Remember, for your logarithm, you know your y's, -1, 0, and 1. 0 always goes with 1. 1 goes with the base, which is 3. And -1 goes with the reciprocal of the base, which is 1/3. So I've got 1/3 -1, 1, 0, 1, 3. Don't forget our vertical asymptote. Okay. Draw my line. And there we go. So that plus 2 is on the outside. So remember the outside causes that to be vertical, so we're going to shift up 2 spots. Okay? Your vertical asymptote does also shift up 2 spots, but since it's an infinite line, it looks like it doesn't really move. So it's just going to basically stay there. But then all of these other points are shifting up. Whoops, that's in the wrong spot. Let's do the last one. All of these points have shifted up 2 spots. Okay, so that's an example of what a vertical shift will look like. Next, we've got our flips. Remember, negatives are what cause our flips. Okay, so the fact that that is negative right there, that's what tells me that it's going to flip. Start with my parent function, y equals log base 1/2 of x. Y equals log base 1/2 of x. Do my table, x's and y's. Remember, I know my y's here, -1, 0, and 1. 0 always goes with 1. 1 always goes with the base. And then -1 goes with the reciprocal. So reciprocal 1/2 is 2. So I've got 2 -1, 1 0, and 1/2 1. Don't forget my vertical asymptote. Okay, so there's my logarithm function here. Now remember, for these, it matters where the negative is for my flip. Okay, so where is that negative? That negative is not on the inside, because remember, to be on the inside, it has to be in parentheses. So this negative is on the outside. And remember, outside causes vertical changes. So that means that we're going to flip this thing vertically. So this point flips up. This point flips down. Okay, the whole function is going to flip vertically. My vertical asymptote flips vertically, but it really doesn't look like it. 1 0 doesn't really flip because it's right on the point that we're flipping. But those other 2 points do flip. And I end up getting this function that has just flipped vertically. It has flipped around. Okay? All right. 2 practice questions that I want you guys to do. Go ahead, pause the video, try this one. It's got 2 shifts with it. And then after you finish that one, you guys can try this one here. Okay? All right. Let's go ahead and do this one here. Okay? The stuff on the bottom actually isn't the order that I would have done these in, but you can still do it in that order and be fine. I'm going to start out with my parent function. This is my parent function here. Draw my table. Remember, x and y, we know our y's. Okay, I've got a base of 2. 0 goes with 1. 1 goes with that base of 2. -1 goes with the reciprocal, so it'll be 1/2. Okay, go ahead and graph those. 2, 1, 1, 0, and then 1/2 -1. Don't forget to draw my asymptote. Okay, so there's my parent function. I like to work on the inside. So I actually would do log base 2 of x plus 1 first. It's not wrong if you didn't do that. But that x plus 1 is on the inside there. So it's going to be a horizontal shift. And I do the opposite. So I'm going to shift everything over to the left 1, which includes my asymptote. All right, so there's everything shifted to the left 1. And then the last thing I'm going to do is I'm going to take care of that negative. Well, where is that negative at? It's not in the parentheses, so that negative is considered on the outside. So since it's on the outside, this is going to be a vertical flip. We're going to be flipping over that axis. Whoops. Okay. So we end up with that vertical flip there. Okay, next one. Again, we're going to start with our parent function. F of x equals log base 1/3 of x. Okay, draw my table, x's and y's. Remember, we know our y's here, -1, 0, and 1. So I've got 0, which always goes with 1. 1 goes with the base. Up there you can see the base is 1/3. -1 goes with the reciprocal, which would be 3. So I'm going to have 3, -1, 1, 0, and 1/3 1. Don't forget my vertical asymptote. Okay, so there's my parent function. Now in this one, again, this is the way I would have done these. Where is that negative at? Well, that negative is in the parentheses, so we'd say that's on the inside. That means this is going to be a horizontal flip. This thing is flipping horizontally. So for this one, my asymptote doesn't move because it's right on the axis where I'm flipping, but everything else is flipping over to the other side. And then the last thing I have is I have this +1. Where is that +1 at? Well, it's not in the parentheses, so that means it's on the outside. So that is going to shift everything up one spot, including my asymptote. It just doesn't look like it really moved at all. Okay, so there's an example of each of our shifts. And again, we are going to talk about our domain and range, but I'll just save the domain and range until we're in class to talk about that stuff.